Today let's see an activity on diffusion. This activity is in lesson 1. According to the new pattern of Telangana state, right, you have 6 marks for activity in the last section, 6 marks. So concentrate well on the activities in the lessons. And we have an activity on the board right now, activity on diffusion. This is in first lesson. First of all, what do you understand by diffusion? Spreading. Somebody says somebody is preparing biryani. Few meters away from our house, we get the smell. Now, who is carrying the smell to you? It is not solid. It is not liquid. It is gas which is carrying the smell to you. Somebody is wearing jasmine, say. Somebody is wearing jasmine. Or somebody opened the lid of the perfume bottle. We get the smell. We may not notice the smell, but we feel the smell. Means who is carrying the smell? It is gases which carry. That is what you mean by diffusion. Now coming to diffusion, it also depends upon mass. Diffusion of gases, right, depend upon mass. If a gas has more mass, then its diffusion rate will be less. If a gas has less mass, then its rate of diffusion will be more. Okay. So for this, I will connect one example in our day-to-day life. Say these two are points. Let us consider the point 1 and this is point 2. So we are now having a running race. I am going to conduct a running race between two students, but in a different way. Actually, running race means what? Both will run from the same side and reach the other side. Now I want to change it, right? I want to make a student by name A here, and for him the finish line is this one. This is the finish line for A. This is the finish line. I am making B student to stand here and he has to run this way. So this is the finish line for B. B is running this side, therefore finish line for B is this one. A is running that side, so the finish line of A is this one. But interesting thing, both of them will start the race at the same shot. That means on your mark, get set and go, fire. For both of them, the starting time is same. Now what happens is the change. Now notice the change. This A is 120 kg, while B student B just 40 kg. Right, and suppose let us divide this total area into two halves. Yes, like this, two halves, two equal halves. This area, whose area is this one? Area belongs to which one? B. This is area B. This one, this is area B. This is area A. Means what? A has to run this side. This is half, midpoint. So this is A's area. This is A's area. Now B has to run from here to here. For B, this is the finish line. So this is B's area. Once he crosses half, then B will enter into A's area. A is running that side, so after half, A will enter into B's area. It's understood, right? Okay. But tell me, for your expectation, who will win the race if this is the case of mass? If this much variation is there in the mass, who will win the race? 100% what you said is correct. 40 will win the race because his mass is less. You can even connect this to physics little bit. Say acceleration, is inversely proportional to mass. Acceleration is inversely proportional to mass. Compared to A, B's mass is less. So his acceleration will be more. Compared to B, A's mass is more. So acceleration will be less. Isn't it? That's it. Very good. Now I will change that acceleration into rate of diffusion, speed of diffusion. So I changed it to speed of diffusion. Very interesting. Nothing changed. If the mass is more, spreading. Gas molecules move, isn't it? If the mass of those gas molecules is less, the spreading will be more. If the mass of the gas molecule is more, 120, then automatically rate of diffusion will be less. Now B will start from here and he will run this side. A will start from here and run this side. Both of them has to cross each other. Quite natural, because the race is like that. A is running that side, B is running this side. For both of them, race starts at the same time. Now you tell me, where do both of them meet? Quite natural. Some students immediately say that both of them will meet in the center, like the center they say, but it is wrong, because B's rate of diffusion is more, while A's rate of diffusion is less. That means A's speed of running is less because his mass is more. Rate of diffusion is less. His mass is less, so rate of diffusion is more. Therefore, what happens, B will meet A in his area only. Yes, very good. B's speed is more, therefore he will cross his half and he will meet A in his area. So I'll go to the now I'll be going to the activity. Before that, let me tell you once again. See, his mass is more, so his rate of diffusion is less. His mass is less, so rate of diffusion is more. So what happens is, since his rate of diffusion is more, since his speed is more, that's what I am saying. So automatically B will meet A in his area, in A's area. Very good. Now I will come to the activity phase. Activity in terms of chemistry. Yes, activity in terms of chemistry means lesson. So he is telling, take a test tube. Okay, done. Take a test tube which is open on both ends. Okay, I took a test tube which is open on both ends. Now place it over a stand so that it remains like this steady. Okay, right, very good. So I took a test tube and I arranged it like this. Both ends are open for the test tube. I took two china dish containers, small bowls, okay, bowls. One is filled with HCl, other one is filled with ammonia, NH3. NH3 means it's ammonia. This is hydrogen chloride. Very good, right, it's here, hydrogen chloride, or you can even call hydrochloric acid, but it is a what you can say, dilute one. Right, now take two cotton plugs. Right, cotton plugs. Suppose just now I told you that 120 kg is running towards left side and 40 is running towards right side. If I actually, who will win the race? 40, because its mass is less, rate of diffusion is more. If I want 120 to win the race, what shall I do? Right, what shall I do? Tell me. I should ask 120 to run. Then afterwards I should restrict 40 and say you run after 2 to 3 minutes. Then automatically 120 will win the race. But that's not correct, isn't it? Everybody knows that it is not correct. What is correct? Both of them should start the race at the same time. Same way, take two cotton buds. I will tell you now. Look. You arrange the test tube. Okay, with test tube is open on both ends. You took two containers. One is with HCl. One is filled with NH3. You are taking two cotton plugs. Dip them into the bowls, and at a time, because race is also same. It's at a time for both. One gunshot, both have to run. Same way, take cotton plugs, 1, 2, 3, and at a time you have to fix it to the open ends of the test tube. Very good, at a time. So, both are fixed to the open end of the test tube at a time. So, this is half of it. Now, this is what NH3. As I said just now, NH3. This is HCl. Now, what happens, you will get a ring between these two. Actually, these two are reactants. NH3 is a reactant and HCl is also a reactant, and you will get ammonium chloride here, NH4Cl. A ring will form. White ring will form. And that white ring is ammonium chloride. Ammonium chloride, NH4Cl. This I just now told you, ammonia and this is hydrogen chloride. When these two react actually, because diffusion is taking place, gases come out from here, gases also come out from here. So when these gases come out and mix up each other, a white ring is formed. Do you know interesting thing? That white ring is formed very close to HCl. What is that white ring? Just now I said NH4Cl, ammonium chloride, and that ring will form very close to HCl. Now what do you understand by this? Tell me. See, ring is formed when these two react. Ring is formed when these two gases react. So now white is not forming in the middle. That means rate of diffusion change is there. Among these two, HCl's mass will be more. NH3's mass will be less. How can you say that? Because its mass is less, so rate of diffusion is more. Therefore, NH3 crossed its area and met HCl in its area. Just now I told you, 40 kg, 120 kg. 40 kg person will cross his area and meet 120 kg in his area. Why? Because his mass is less, rate of diffusion is more. Now we'll check out the mass. So let me say HCl. So hydrogen is 1 and chlorine is also 1. Hydrogen is 1 and chlorine is 1. Hydrogen atomic mass is 1. So 1 into 1 is 1. Chlorine mass is 35.5. So therefore what happens? It's 1 plus, I'll write down here. So it is 35.5. So 0.0 and 0 over here. So the answer is 36.5 gram. Okay, you got HCl as 36.5 gram. That means NH3, the mass of NH3 will be less than this one, Pakka. How? Since its mass is less only, it is able to cross its area and meet HCl in its area. In its area. That means they are Pakka. We'll see now NH3. N is how much here? 1. 1 into atomic number of nitrogen is 7. So mass is 14. So 1 into 14 is 14. What about H? H is 3. H is 3 and 3. 1 into, 3 into, right? Its mass is always 1. 3 into 1 is 3. Therefore, on the whole, the answer is 17 gram. Confirm, super. Mass of NH3 is just 17 gram, while the mass of HCl is 36.5. That means mass here is more, acceleration is less. Mass here is less, so acceleration is more. That is why NH3 met HCl in its area. So a white ring NH4Cl will form here. And where is that NH4Cl? Close to HCl. Because mass of HCl is more. This is what you mean by diffusion of gases. All gases do not diffuse at the same rate. No, they don't diffuse with the same rate. The diffusion of the gases depend upon their mass. Right, thank you.